Good evening to all those who have logged in. Today I am going to take up carboxylic acids and their properties which you know it, but I would like to explain, or I would like to bring to your kind notice some of the properties which you already know. After that, I would like to explain the acidity of carboxylic acids. So, properties, then acidity of carboxylic acids. So, in the previous class, I explained what are carboxylic acids, their preparation, some important IUPAC names. I mean the IUPAC names of some important carboxylic acids. So, we shall take up. So, before starting today's explanation, the questions most students got wrong from the last CPP. The IUPAC name of palmitic acid is see, palmitic acid is 16 carbon atom monocarboxylic acid or fatty acid. So, 16 is hexadecanoic acid. Octadecanoic acid, as I heard that many of you have answered, is stearic acid. It is stearic acid. Stearic acid has got the formula CH3, CH2, 16 times COOH, stearic acid. Good evening, Mansi, Radhika, Smarnika, Sunil, to all of you, 4 good evenings. Okay, right. So, octadecanoic acid is stearic acid, hexadecanoic acid is palmitic acid. Before I go to the other acids, please note that all naturally occurring fatty acids contain even number carbon atoms. Important. All naturally occurring fatty acids have got even number carboxylic acids. On the basis of that, the human evolution has taken place, our digestion system has been based Krebs citric acid cycle, where it is converted into acetyl coenzyme A. Each time 2 carbon atoms are involved in the reaction, etc., etc. That is why you have lauric acid with 12 carbon atom, myristic acid with 14 carbon atoms, palmitic acid with 16 carbon atoms, stearic acid with 18 carbon atoms, naturally occurring ones. Okay. Now, properties of carboxylic acids. Today's goal, properties of carboxylic acids and their acidity, effect of substituents on acidity. So, properties, I will list the properties, you know it. If you answer it quickly, I will proceed further. Reaction of carboxylic acid with sodium hydroxide, sodium carbonate, calcium hydroxide. Then reaction with CaOH twice and NaOH, that is Sodalime. Then reaction with PCl5, reaction with thionyl chloride. The next one is reaction with ammonia in the cold condition and in the hot condition. Then electrolysis of sodium salt, Kolb's electrolysis. Then after Kolb's electrolysis, HVZ reaction, Hell-Volhard-Zelinsky reaction. Then reaction with P2O5. So these are the reactions which I want to write and if possible discuss with you. Reduction with aluminum, lithium, aluminum hydride, etc. Okay. So with sodium, you know it, RCOOH plus Na, it becomes RCOO Na plus H2. Simple reaction, just like alcohol. Carboxylic acids also react with sodium, liberating hydrogen. H is acidic, can be replaced by sodium. RCOOH plus NaOH, simple, RCOO Na plus H2O. This is a base, this is salt, this is water, therefore it is acidic, carboxylic acid. Okay. So anybody you can tell me, how do you test an acid? How do you test an acid? Anybody who can tell me, how do you test an acid? Test for acid, test for acid. The acid may be HCl, acid may be H2SO4, acid may be formic acid, acid may be acetic acid. Which is the test you conduct? Anybody? Radhika, Sunil, Mansi. How do you test an acid? Litmus test. Okay. Can you give me a chemical test? Actually, it's litmus test is also a chemical test. Anybody who can tell me what is litmus? Okay. Soham Rastagi, using indicators. Okay. What is litmus? Since you have given Rastagi, you have given litmus. Can you tell me what is litmus? Yes? Right, you think over. Then any other test? Sunil, Smarnika, any other test? Indicator, litmus is also an indicator. It turns blue litmus red. It turns phenolphthalein colorless. It turns ester test. Okay, ester test, sodium hydrogen carbonate. Good, very good, Smarnika, very, very good. Ester test is only for organic compounds. Soham, ester test is only for carboxylic acids, not for all. The one which has been given by Smarnika, sodium hydrogen carbonate. So, you take any acid, you take any acid. I will take organic acid, CH3 COOH. You treat it with sodium bicarbonate, baking soda. There will be effervescence with the liberation of carbon dioxide, COO Na plus H2O plus CO2, sodium hydrogen carbonate. Yes, Akshay, good evening, very, very good evening. So, it can be tested by using sodium bicarbonate or sodium hydrogen carbonate. You can see the effervescence. If you pass, you can test carbon dioxide by passing through lime water. The lime water turns milky. So, you can test that also. So, carbon dioxide effervescence. Anybody who can tell me what is effervescence? You use the word effervescence every now and then, and the teacher also uses. Can you tell me what is effervescence? What is the meaning of effervescence? Okay, right. So, sodium bicarbonate, you can effervescence takes place with the liberation of carbon dioxide. Base turn turmeric red, okay, does not matter, but say in turmeric you have to know which part of turmeric turns red, okay, right. Bubbles in liquid, yes. Effervesce, the meaning of English is to boil. Effervesce is to boil. Earlier they were using it they were using it for fermentation reactions, effervescence. Now we use it for chemical reactions where comes in sodas, yes, the white phase, okay. So, carbon dioxide effervesce is to boil. When carbon dioxide is coming out, you feel as though the liquid is boiling. You can see the bubbles as you said earlier, okay, fine, good. The next one is reaction with calcium hydroxide. Again, acid plus base, it results in the formation of a salt, CH3 COO twice Ca. Usually the calcium salt is prepared to prepare something else from that. If you dry distill it, you get CH3 CO CH3 propanone. Otherwise, calcium salt is of no use. So, calcium salt on dry distillation gives either an aldehyde or a ketone. So, this gives a ketone. Suppose you have an aromatic acid like benzoic acid. Suppose you have benzoic acid C6H5COOH, you get C6H5COO twice Ca, calcium benzoate, and you get benzophenone. Benzophenone. Usually calcium salt is used to prepare something else from that. Okay. The next one, reaction with Sodalime, which you already know, or COOH plus NaOH plus CaO. If you heat the mixture, first it forms RCOONa. This RCOONa, if you heat it, again react with sodium hydroxide, giving sodium carbonate, and you are left with alkane. This is decarboxylation reaction, elimination. Elimination reaction, decarboxylation reaction. So, if you heat it with soda lime, it forms RH. Here I would like to ask you a question. So, the reaction is RCOOH plus NaOH gives rise to RCOO Na. This will react with NaOH to form Na2CO3 and RH. Na2CO3. So, Yusra, Sheikh, Rastagi, Soham, Rastagi, Mansi, Radhika. The question is, what is the function of calcium oxide in this reaction? Because we use Sodalime. Sodalime is CaO plus NaOH. But in the reaction, I have used only NaOH. What is the function of CaO here? Anybody? Clear, Smaranika, yes. Can you tell me the function of CaO? Absorb carbon dioxide, okay, fine. So, to a little extent CaO will absorb carbon dioxide giving CaCO3. That is a minor part. Any other answer? Radhika, one of the answer is that, but it is a minor one. What is the major role played by CaO? Calcium oxide, that is quicklime. Okay, helps in the splitting, maybe, maybe correct. Whatever answer you want to give, you give the answer. You should think and give the answer. It may be wrong, doesn't matter. Okay, I will give you after 2 minutes, you think over. Right. The next reaction which I am going to give you is reaction with PCl5 or SOCl2. RCOOH plus PCl5 will give rise to RCOCl. You already know PCl5 thionyl chloride replace OH group by Cl. So, you get RCOCl plus POCl3 plus HCl. POCl3 plus HCl to help in carrying out the reaction in high temperature. Any other answer? Any other answer? Okay, I will give you another half a minute time. So, this RCOCl reacts with ammonia giving RCONH2. It forms an amide. High temperature it can be, I think, Radhika. Okay. So, with PCl5 or with SOCl2, you get RCOCl acid chloride. This acid chloride reacts with ammonia forming an amide or amide, acid amide. Okay. Coming back to your question, calcium oxide. See, sorry. NaOH is a deliquescent substance. A deliquescent substance. Yes, Smaradika, right. You got the exact point of the answer. It is a deliquescent substance, absorbs moisture. Absorbs moisture. When it absorbs moisture, its reaction with acetic acid etc. becomes very, very slow. Yes, Therefore, to keep NaOH in the dry condition, calcium oxide is used. So, to keep sodium hydroxide in the dry condition and to help for the reaction, and the other part is CaO can also take up, as Radhika has said, can also take up carbon dioxide to form calcium carbonate. Yes, reaction to take place relatively. So, it keeps sodium hydroxide in the dry condition, right? You are right, Radhika, and then Smarnika. Yes, it is correct. Okay. Now, so we have seen the reaction with sodium over sodium hydroxide over sodium carbonate over calcium hydroxide over PCl5 over then lithium aluminum hydride, ammonia, etc. Lithium aluminum hydride, you already know the reaction. Yes, or COOH with lithium aluminum hydride. It gives rise to RCH2OH. A primary alcohol is obtained. Primary alcohol is obtained. Next one, reaction with ammonia. Ammonia is a base. Carboxylic acid, it is an acid, therefore, it results in the formation of a salt. Ammonium salt of carboxylic acid or ammonium carboxylate. If you heat it, it loses a molecule of water, dehydration, resulting in the formation of RCONH2. An amide is obtained. An amide is obtained. Now, I will heat this amide with P2O5. Can you give me the product that is obtained? Anybody? Yes, an amide with phosphorus pentoxide, if you heat it, what do you get? An amide when heated with phosphorus pentoxide or CN. Okay, Manasvi. Yes, H2O, P2O5 is a powerful dehydrating agent. I have already told you P2O5 is more powerful dehydrating agent than sulfuric acid. Therefore, H2O will be removed. You get RCN. Very good. Yes, Radhika. Manasvi, Radhika. Very good. Okay. So, if you treat a carboxylic acid with P2O5, same reaction, yes, Nagavini, you are right, RCN, with P2O5, dehydration takes place, giving CH3, CO, CH3, CO and O. Acetic anhydride is obtained. Acetic anhydride is obtained. Nitrile, Smarnika, you are right. Nagaveni, Radhika, Manasvi, all of you are right. It gives a cyanide. So, acetic acid when heated with phosphorus pentoxide undergoes dehydration, giving acetic anhydride. Acetic acid minus water is acetic anhydride. Acetic acid minus water is acetic anhydride. On the basis of this, can you give me what is the formula of sulfuric anhydride? Sulfuric anhydride. Sulfuric anhydride. Or sulfurous anhydride. Sulfurous anhydride. The formula of sulfurous anhydride, sulfuric anhydride, or carbonic anhydride. Carbonic anhydride. Carbonic anhydride. So, nothing is coming on the screen now. Nothing is coming on the screen. So, carbonic anhydride, anybody? Sulfuric anhydride, sulfurous anhydride, carbonic anhydride. Carbonic anhydride. Anybody who is answering the question, what is the formula of sulfuric anhydride, sulfurous anhydride, and then carbonic anhydride, etc. Sulfuric anhydride, sulfurous anhydride, etc. Yes. Okay. So, I will we go to the next property, HVZ reaction. HVZ, yes, SO3, Radhika, you are right. SO3 sulfuric anhydride, CO2 is carbonic anhydride, SO2 is sulfurous anhydride. So, this is carbon dioxide, this is sulfur trioxide, this is SO2. Yes, ethanoic anhydride. Acetic anhydride is ethanoic anhydride. Okay. The next property is HVZ reaction. HVZ reaction. Yes, all of you are right. Smaranika, Yash Pratap Singh, Radhika. Okay. Now, if you have alpha hydrogen atom in carboxylic acid, that alpha hydrogen atom can be replaced by chlorine, bromine, etc. in presence of red phosphorus. In presence of red phosphorus, this reaction is called HVZ reaction. HVZ reaction, Hell-Wohlhard-Zelinsky reaction. Hell-Wohlhard-Zelinsky. Hell-Wohlhard-Zelinsky reaction. If you treat it with chlorine or bromine in presence of red phosphorus, alpha hydrogen atom is substituted by chlorine. So, we shall write an example for this. CH3 COOH plus Cl2 in presence of red phosphorus, it will give CH2Cl COOH, 2-chloroethanoic acid, 2-chloroethanoic acid. Suppose you use CH3 CH2 COOH, same reaction HVZ reaction, it will give CH3 CHCl COOH. Santosh Aryan, very nice. Okay, fine. CHCl. So, this is alpha hydrogen atom is replaced alpha chloroacetic acid, alpha chloropropionic acid, or it is called 2-chloroethanoic acid, 2-chloroethanoic acid, ethanoic acid. This is 2-chloropropanoic acid, propanoic acid. So, replacement of alpha hydrogen atom by this chlorine in presence of red phosphorus is called, yes, Hell-Wohlhard-Zelinsky reaction. Okay, right. Then in this case, before I go to acidity, an important part of carboxylic acids, then we shall take up the first carboxylic acid, very first carboxylic acid, formic acid. See, in the periodic table, the first element lithium, the first element beryllium, first element boron, similarly first element fluorine, first element helium, they are exceptions to that particular group, exception to that particular group. Similarly, in carboxylic acid, formic acid or methanoic acid is an exception. What is that exception? It has got the dual nature. What is the dual nature? It behaves, see, formic acid, it reduces very peculiar, formic acid reduces Fehling's solution to red precipitate of cuprous oxide. It reduces Tollene's reagent, it reduces mercury chloride, because if you write the structure of that HCOOH, it has got an aldehyde group also. So, HCOOH is an exception. So, it has got the dual nature, that is aldehyde and carboxylic acid. Therefore, it behaves like an aldehyde, hence it acts as a reducing agent. Give an example of an acid which is a reducing agent, formic acid, because it has got an aldehyde group. So, it will reduce toluenes, Fehling's, mercury chloride, etc. Okay. So, these are the properties, some of the properties which I wanted to explain. Now, we shall go to the acidity of carboxylic acids, acidity of carboxylic acids. So, before I go, see, the question is COOH, yes, Malana, yes, HCOOH, HCOOH has got the dual nature. Okay. Acetic acid, formic acid, CH3 CH2 COOH, C6H5COOH, ClCH2COOH. We have to decide which one is a stronger acid than other, or out of these which is the strongest acid. All are weak acids. Which is the strongest acid? That we have to discuss. In your first year pre-university or 11th standard, you have studied ionic product of water. Sorry, ionization constant of an acid or dissociation constant of an acid. Yes, Malana, you are right. I will come to that. Suppose you have an acid. Suppose we have an acid or COOH. You dissolve this in water. It results in the formation of RCOO minus and H3O plus. An equilibrium is established. An equilibrium will be established. The dissociation constant or equilibrium constant for the acid Ka is, yes, I will come to that explanation, Jyotsna, then Rostagi, etc. Ka is equal to active mass of RCOO minus into active mass of H3O plus divided by active mass of RCOOH. Ka is called the dissociation constant of an acid. If H3O plus concentration is more and more, Ka is more and more. Therefore, Ka is directly proportional to the strength of the acid. Ka is directly proportional to strength of the acid. Now, coming to the values. Now, between HCOOH and CH3COOH, you know that Ka of acetic acid is less than that of formic acid. Ka of formic acid is greater than acetic acid, means acetic acid is a weaker acid than formic acid. Ka of CH3CH2COOH is less than CH3COOH. Ka is less than Ka of this, means propanoic acid is weaker than acetic acid. Propanoic acid is weaker than acetic acid. ClCH2COOH, Ka value is greater than, I am coming to your answer, Jyotsna, Soham, Rastagi. Yes, I will come to that. Still we have 7 minutes time. ClCH2COOH is Ka greater than acetic acid. Therefore, this is a stronger acid. Stronger acid. Okay, going back. If COOH is connected to plus I groups, Ka value decreases. Ka value decreases. Acid becomes weaker. If COOH is connected to minus I effect group, plus I effect group, CH3, C2H5, etc. minus I effect group like Cl, Br, NO2, etc. then Ka increases. When Ka increases, the acid strength increases. Acid becomes stronger. You already know this. I would like to explain. Yes, acidity decreases. Manasvi, you are right. So, Before I explain this acidity, we shall go to the contest question, effect of substituents on acidity. Previous class contest question: which of the following chemical is added in washing powder to keep it dry? Sodium silicate is the answer. Previous class contest question. Winner is Monsi. Therefore, an atom session is added to her name, sodium silicate. Now, today's question, contest question, very easy. Which of the following gives effervescence with baking soda, reduces Hg2 plus to Hg plus, reduces alkaline copper sulfate and Rochelle salt to red precipitate of cuprous oxide. Cuprous oxide. This is today's contest question. Okay, right. The answer has already been given by Mansi, etc., etc. Okay, right. Now we'll go back to the effect of substituents on acidity. Yes, see here, trichloro acetic acid is a very strong acid. Its value of Ka and pKa are inversely related. pKa, if pKa is higher and higher, weaker is the acid. Reverse, because pKa is equal to minus logarithm of Ka. See here the values. CCl3COOH, there are 3 chlorine atoms which pull the electrons. Therefore, its value is 23,200 into 10 to the power of minus 5. Very strong acid compared to acetic acid, because acetic acid CH3COOH, acetic acid value will be 1.75 10 to the power of minus 5. Compared to that, 23,200, 3 Cl groups have got so much effect. 2 Cl are connected to acetic acid. It is 5530 into 10 to the power of minus 5. Oxalic acid has got the first ionization constant of 5400 in 10 to the power of minus 5. 2-fluoroethanoic acid 260 into 10 to the power of minus 5, etc. Thus, minus I effect groups increase the acid strength, If minus I effect group is nearer to carboxylic acid group, its strength will be greater. See here, this is 2-chloro and this is 2-chloroacetic acid. This is 139, this is 136. As the electronegativity decreases, Ka value also decreases. So, compared to acetic acid 1.75 in 10 to the power of minus 5, chloroacetic acid is 136 into 10 to the power of minus 5. It is almost 70 times stronger than this. Now, benzoic acid has got 6.3 into 10 to the power of minus 5. CH3COOH, paramethyl benzoic acid, is 4.2 in 10 to the power of minus 5, means it is weaker because CH3 group is an electron pushing group. NO2 is an electron pulling group, therefore, it is 36 almost 6 times that of benzoic acid. So, plus I effect groups increase, minus I effect groups decrease. So, plus I Ka decreases or pKa increases. The acid becomes weaker, whereas minus I effect Ka increases, pKa decreases, the acid becomes stronger. Okay. So, with this it is time up. I will conclude the session. So, today I explained properties of carboxylic acids and their acidity, effect of substituents on acidity. Day after tomorrow, listen to me, all of you, Jyotsna, Smaranika, Radhika, Malana, Rastagi, Mansi, Manasvi, all of you, listen to me. Day after tomorrow is my last class, where I am going to discuss some questions along with some multiple choice questions. Some direct questions I would like to ask you and get the answer, and then some multiple choice questions. Okay. Thank you for joining. Now, get the passport, the question, get the access to the class practice packs sent by me with the passport. Thank you very much. So, all the best. Okay. Bye.